In this segment, we're going to talk about neural net chatbots. And we're going to see that chatbot systems have dramatically advanced since some of those early systems that we talked about. So here I'm going to give you a kind of crash course in the history and some of the ideas that led to where we are now with these chatbots, from some of the earliest neural networks up through the latest models. So one of the first attempts to make a neural net chatbot was really inspired by machine translation. And the idea was that, well, can we just think about this as a sequence-to-sequence problem, essentially translating from something that someone says into a response to that thing, right? Viewing these almost as like two different languages. And these early efforts even tried to evaluate with metrics from machine translation like BLEU score. However, there's some big challenges with this. So remember that BLEU scores go all the way up to 100, and human BLEU, so you take one human written response and compare it to another human written gold standard response, those have a BLEU score of 6 out of 100. So there's very high disagreement on how humans actually continue a conversation, obviously because there's just many things that can be said, right? So even if a system based on machine translation sort of does okay, it's very hard to evaluate whether it's taking things in a reasonable direction or just kind of getting half the words the same as what a human would say or what. And it turned out that actually these systems were not doing all that well. One of the problems that was observed was that when you train these models on data in this translation-like fashion to maximize the likelihood of the responses, you end up with this kind of degenerate behavior where the models really like to say, I don't know. And I think the second example here is interesting. If I say, what is your name? You're most likely going to tell me your name. However, there are many, many names out there, right? So the probability of saying my name is X for any particular X might be somewhat low, but I don't know is this kind of generic response that works in almost every scenario. So it has this like high prior probability under the model, and then the model likes to produce it all the time. And it's really hard to kind of fight against this. So one of the ways of doing this was to try to imbue these chatbots with personas. So there was a data set collection effort from folks at Meta called Persona Chat, where they had two people sit down and have a conversation, and each person was given one of these personas. And the idea was that if these people sort of say things according to these personas, we can train models that condition on the personas and then are more likely to be able to say the same thing. So when you say, my name is whatever, you actually report a name given in the persona. Or if it's like, what do you like to do? You'll say for persona 2 here, I love watching Game of Thrones. Now, if you look at these conversations, they're a little bit stilted, I think. But regardless, training on this data did lead to somewhat better systems. However, these were still not that exciting to interact with. And so one of the big components, if you've made it this far in the course, you'll be predicting is bigger data and pre-trained models. And so the idea essentially is to say, all right, let's just take this approach and just elevate the data, the size of the model used and everything like that. And there are some other tricks that we've seen so far, like nucleus sampling, that can help as well. Particularly with things like these generic responses like, I don't know. So there were a couple of efforts starting in around 2020. One of the most notable ones, also from Meta, was a system called Blenderbot, which was a 2.7 billion parameter model. So actually at the time, it was one of the biggest models out there. This was shortly after GPT-2 released. And they have a bunch of tricks that we're not really going to talk about, but they have the ability to retrieve from a corpus. So they can kind of have a dialogue grounded in something like a Wikipedia article. And they used a bunch of different data sets, including this prior Persona Chat data set, a data set of empathetic dialogues, and also a data set kind of talking about factual information from Wikipedia. So how does this work? We're going to look at a few examples and try to get a sense here. So in this example, the gray here is the user and the blue here is the chatbot, Blenderbot. So the user says, will you sing me a song? And the bot says, sure, what do you want to be sung to? I can sing you a song about baking. And then the person says, yes, sing me a song about baking. Do you want me to sing it to the tune of Sing Along with Mitch? Yes, I would love that. Okay, I'll get it to you by the end of the day. What else do you like to do? So the system doesn't want to sing you the song yet. So this is already a little bit odd. Of course, it's odd to be trying to sing a song with a chatbot. And then the person says, can you tell me what the lyrics are? Sure, it goes like this. Baking is my favorite thing to do in the world. How does the chorus go? It goes, baking is my favorite thing to do in the world. So I think this is actually kind of a funny bit, but I think it's like funny unintentionally. I don't think the chatbot is trying to make this joke here. I think, it kind of shows that this conversation, maybe it's not really able to follow the intricacies of a multi-turn dialogue yet, even with a pretty big model. However, we see that the responses at least follow what the person asks. They kind of are reasonably coherent. They do make sense, etc. So there's a lot of kind of good boxes being ticked. Now, there's some issues. So the bot will say, I'm from the Midwest, but I live in the South now. How about you? And then the person says, born and raised in the South. And then the bot says, what part of the South? I was born in Georgia, but raised in Tennessee. So kind of immediately switching up and being inconsistent about information. So that was one of the things that Persona Chat was designed to avoid. And we still see that that's happening somewhat. So it's not as good as kind of conditioning on these past conversation turns. And then finally, there's this interesting joke explaining example. Why did the mushroom go to the party? I'm not sure, but I'm glad it did. I love museums. What do you do for a living? So again, not really being a kind of helpful conversation partner here. No, it was supposed to be a joke. Oh, sorry, I didn't get it. What kind of joke was it? I like jokes. The answer is because he's a fun guy. Do you get it? No, I don't. Can you explain it to me? Yes, mushrooms are fungi, and fungi is pronounced like fun guy. And then the system says, I get it. And then the person asks for an explanation, and then the system can kind of explain it back. So this is kind of an interesting, I think this example sort of highlights something interesting here. These issues with the model, there seems to be a little bit of inconsistency and not a strong ability to use the context. It also feels like this, you may be kind of talking to someone here, but there's something kind of missing. And one of these things is that, of course, the model didn't actually learn this joke in that no parameters were getting updated. It does learn it in kind of an in-context sense where it's able to look at the kind of the conversational context and re-explain the joke. But there's also a sense in which the model doesn't really understand phonology, right? So like how much can we say that it really understands this joke versus this allowed it to surface something from the pre-training data, because this is a pretty common joke. So there's a kind of interesting philosophical direction that this leads in thinking about sort of what is intelligence and kind of getting back to the ideas of the Turing tests and are we interacting with kind of something real here. And this came up with a subsequent model from Google called Lambda, where an engineer at Google claimed that this was a person and self-aware and was subsequently fired. And there was a whole kind of kerfuffle about this. So I think questions about what is consciousness and things like that are a little bit outside the scope of this course. But what I will say is that when we look at the kind of next big system that was released after Lambda, which was ChatGPT, this system does not really look like these other chatbots, right? It's very on rails, and I would describe it much more like a QA system than a chatbot. So the system will really kind of not want to go off into like some weird direction with you. It'll instead want to provide information and has a lot of this fencing where if you try to get it to go in weird places, it'll say like, oh, as an AI language model, I can't do that. So I think the reaction to things like Lambda have kind of led to those design choices for how to implement and release these systems. I will say that there are other players in the space like Character.ai, which is a startup that is trying to deliver more on the kind of chatbot vision using the latest and greatest models. So we're likely to see more advances in this vein over the coming years and months. That's the end of this segment.